Hello guys, welcome to PLACEBOTOEDU and my name is Vinay Kumar Nainapatrani. Today we are going to discuss divisibility rules category 2. So what is this category 2? Let us discuss. I've already discussed basic divisibility rules and this category 2 represents prime numbers. So today we are going to discuss divisibility rules of prime numbers. Before going into discussing the divisibility rules of prime numbers, let me give some examples how to do that. If you see here, is 361 divisible by 19? That's one question. And is 121 divisible by 11? I've taken very small numbers in order to explain you that clearly. So considering the first question, 361. We have a procedure for all the prime numbers. This is the only procedure we have to do and I will explain that. Please follow. Considering 361. Okay. Here the last digit is 1 and the remaining digits are 36. 3 6. Okay, the last digit is 1 and remaining digits are 3 6. Now what we have to do is we consider the last digit and multiply it with 2 and add the total to the remaining digits. Understood? We consider the last digit and multiply it with 2 and it will be added to the remaining 2 digits, and then we will get answer 36 plus 2, which is 38. If this number is divisible by 19, then the whole number 361 will be divisible by 19. Understand? So 19 twos is 38. This is divisible by 19. Therefore 361 is divisible by 19. Understand? The same technique we will follow here. I'm considering 121 here. The last digit is 1. That is, I have to write here. And the previous digit is 12. And now I will subtract. And the 1 is multiplied with 1. So we'll get the answer as 11. If this is divisible by 11, then the number 121 will be divisible by 11. Is that clear? Now I will come into generalized form of this divisibility rule. So see that. If you observe carefully, here I multiplied with 2, but here I multiplied with 1. So the number which is multiplied to the last digit is known as oscillator. I think it's the new term which you are listening for the first time. So I will be giving the types of oscillators and then we are going to discuss every divisibility rule of prime number. So oscillator, 2 is oscillator and here 1 is oscillator. What are the types of oscillators? For discussing the types, observe here I added the product to before 2 digits. Here I subtracted the product with the 2 digits. Based upon that, the oscillators are divided into positive oscillators and here it is said to be negative oscillator. What all come into positive oscillator and what all come into negative oscillator? Let us discuss. Here is a list of prime numbers from 1 to 100 and the numbers which are highlighted with yellow are prime and which are highlighted with white are composite. With a keen observation, you can observe that the prime numbers have 1, 3, 7 and 9 as the last digits. Understood? We have 1, 3, 7, 9 as the last digit for every prime number. I'm not discussing about the first row, just discussing about the other remaining rows. Okay, so 1, 3, 7, 9 are the numbers digits which are at the last of prime numbers. From that, 3, 9 are known as positive oscillators and 1, 7 are known as negative oscillators. So we have the same rule for the digits which are ending, for the numbers which are ending with 3, 9, and we have the same rule for the numbers which are ending with 1 and 7. Considering the prime numbers which are ending with 9, that is 19, 29, 59, 79, okay, and so on. So the rule is the oscillator will be 1 plus to the digit which is in front of 9. For example, here the digit in front of 9 is 1. So here it will be 2 for 19. The oscillator will be 2 for 19. And for the next thing it is 2. So 2, 1 plus 2 which is equals to 3 for 29. So the oscillator for 29 is 3. Understood? I think you guys get that. And for 59, the oscillator is 1 plus 5 which is equals to 6. Understood? So we got the oscillator. Now I will give you the example how we use that oscillator. For every prime number, the procedure is same. Understand? For example, consider a number 145. Is this divisible by 29? This is the question. So what I have to do is, I have to consider the last digit, that is 5, into the oscillator. What is the oscillator of 29? It is 3. So I have to multiply it into with 3. Okay, and this should be added, since we are discussing 9 which is a positive oscillator. So I'm adding that. And what are the remaining two digits? 14. So we got the answer as 14 plus 15 which is equals to 29. Since 29 is divisible by 29, 145 is divisible by 29. Understand? Is that clear? If you have any doubts, please comment below. I will answer regarding that. Next, coming to the oscillator which have the digits ending with 3. You have to observe that this is also a positive oscillator. So for 3, what we do is that we change it into 9. So the number which is ending with 3 should be multiplied with 3 such that you will get the last digit as 9, and we have to follow the same rule of 9. For example, consider 117. Is 117 divisible by 3 or 13? Is 117 divisible by 13? Okay, so what are the prime numbers we have that is ending with 3? 13, 23, and 43, and so on. These are all the prime numbers which end with 3. So I gave the example 117 divisible by 13. For this, what I have to do, the given number must be multiplied with 3. 7 into 3. Okay, first we will do that, and which we get 351, and we have to multiply this also with 3. So we have 13 into 3 which is equals to 39. Now what we have to see is 351 divisible by 39? So how can we do that? We have to see the number which is before 9, that is 3. So 3 plus 1 is 4, and the last digit of 351 is 1. So 1 into 4. Since this is a positive oscillator, we will add, and the remaining digits are 35. So the answer is 39, and 39 is divisible by 39. Therefore, 117 is divisible by 13. Is that clear? I hope it's clear. Now, coming into the next thing, 1. So the numbers which, prime numbers which are ending with 1, that is 11, okay, 31, and so on. 1 is a negative oscillator. You have to observe that. So how the oscillator will be? For 1, the oscillator will be the previous number to the 1. For example, if it is 31, the oscillator is 3. If it is 11, the oscillator is 1. Understood? So coming to the example, I will be giving you the example such that you can get it very clearly. Example 1331. Is this number divisible by 11? I've already told you that the oscillator for the numbers which are ending with 1, the oscillator will be the previous one. So here the oscillator is 1. Therefore, the last digit is 1. I'm considering the last digit product with the oscillator, which is 1. And since the 1 is negative oscillator, I have to subtract it. So I am subtracting it from the previous digits, that is 133. So I get 132, which is divisible by 11, that is 11 12s 132, and therefore we have 1331. 1331 is divisible by 11. Understand? I think it's very clear, right? So next one, for next one we have to see 7. 7 is also a negative oscillator. So the numbers which are, so the prime numbers which have 7 as ending, that is 17, 37, 47, and so on. For this type, what we have to do is we have to multiply it with 3. 7 3 is 21, so that we will get, it will change into the form which has 1 at ending, and we will continue with the rule which we already discussed for 1. For example, consider 187. Is 187 divisible by 17? This is the question. So what we have to do, we have to multiply the 187 with 3. So I am multiplying 187 with 3, which I get 7 3 is 21, 561. Okay, and I have to multiply 17 into 3, which I get 51. So now what I have to do is 561 divisible by 51 or not? Since 1 has, 1 is last digit of this, the oscillator is 5. So taking the 5 into consideration and multiplying it with the last digit of 561, plus since 7 is a negative oscillator, I have to keep negative sign, and the remaining digits are 56, which I get 51, which is a multiple of 51. Therefore 187 is a multiple, is divisible by 17. Understand? Is that clear? In this way, we can get divisibility rules of any prime number. Hope you guys liked it. Thank you.